Without further ado, we're excited to have Randolph. He told me he's hailing from Calgary, right? And
that's correct.
They're expecting snow soon.
Snow on the weekend, yeah.
Snow for the weekend. All right. It's all yours, Randolph.
Thank you very much. Thanks, Bill. Hi, everyone. Thanks for inviting me again, Carlos. I was the original speaker at the very first SQL Trail back in 2017, and I got this cool T-shirt when I was there. So I thought I'd represent some original colors. It's good to be back again, and I'm just going to dive into my slides immediately. So let's click share screen and see what happens if I choose this button. And then I go to PowerPoint by going to, where's PowerPoint? There it is. Just as well, we're not recording my embarrassing moves. Cool. Welcome, everyone. We're going to be taking a practical look at temporal tables today. For those of you who may have seen my variation on this called Back to the Future with Temporal Tables, the demos are very, very different because we're actually going to do a walkthrough of a real world example of using temporal tables. But if you have seen the presentation before, the slides are quite similar because there's only so many ways to talk about temporal tables. I'll try and mix it up a little. If you haven't seen that, then we're good. Then you're going to be learning. I do encourage folks asking questions along the way. We have Bill as a moderator, and I obviously cannot see the Q&A right now because I'm sharing my screen, but please feel free when I'm taking a sip of my water or when I ask for questions, please feel free to say something. So I call myself a free cell enthusiast. I call myself a lot of things. I've been doing this for a while. I've already said this, please ask questions. Oh, if I like your questions, then I'm allowed to give away t-shirts. I'm allowed to give away four t-shirts. So feel free to ask questions. I like questions that are difficult, especially if I don't know the answer, because then that means I get to write a blog post about it. So please go ahead. Who is Randolph West? So I told a few people once upon a time that I liked being on stage, and now I'm a professional actor. I do more voice work than on-camera work, but I've done a lot of independent features. I've also written some books. 3 out of the 4 books I've contributed to are about SQL Server, and they're the pictures on the right. I'm also a Microsoft MVP for 5 years now. I am on the board of the Azure Data Community. So after PASS imploded at the end of last year, the initiative from Microsoft to have a self-managed community organization was created, and they created what is the first of the board that represents the community, not Microsoft. So if you have any issues and you're part of the Azure Data Community, you approach the board, and then the board tells Microsoft what to do. It's not like the previous way of dictating how things should run. I'm also on the in the collective for managing the Data Saturdays website, and of course my own company branding is there, because what are we here except selling ourselves? My pronouns are they and them. My email address is right here. If you have any questions about temporal tables or SQL Server in general, please feel free to reach out and ask me. I like C#, SQL Server, and chocolate. So let's get into it. There are 2 now since June. I think it was June when it was made into a preview. There are 2 ways of doing system version tables in Azure SQL DB, and currently 1 way of doing them in SQL Server. Now, if history is going to dictate anything to us, it's going to say to us that this feature will eventually make it into SQL Server 2022, probably is the next version. I don't know, because even the MVPs don't know, but we would expect to see both of these system version types being made available in the boxed product. But for now, temporal tables are the only one that are in SQL Server and Azure, whereas ledger tables are Azure SQL database only. I will briefly talk about ledger tables. The whole deal there is that they're a fairly new feature. They're not in SQL Server itself. So because it's so new, I'll only just mention it where it makes sense. Otherwise, we're going to be looking specifically at temporal tables. So system versioned temporal tables. What are they? Well, they keep a full history of data changes. What that means is if you make a modification to your table, like a delete or an update. Sorry, I was thinking CRUD, C-R-U-D. If you do a delete or an update, it takes a copy of the row that is being modified, whether it's being deleted or being updated. It takes that old row and puts it into a history table. And that history table is managed by the system. So that's why it's called system versioned. It keeps a full history of the data changes. It allows easy point-in-time analysis. So you can write a temporal select query, and I'll show you the keywords for that in the demo, and you can ask for data at a specific point in time. So that makes life very cool if you have to look up historic data. Each row has a version, and that version is indicated in different columns. And the period of validity for each row is managed by the database engine. In other words, you don't have to worry about things like when was the row updated, how long is it valid for. That's why it's called system versioned temporal tables. Excuse me. A temporal table needs 2 period columns, a valid from and a valid to. The name that I've just described to them are whatever you want to call them. In some of Microsoft's documentation, they call them sys_start_time and sys_end_time. Valid from and valid to is one of the naming conventions that they've used in the Wide World Importers database, which does have temporal tables if you want to play with them in there. The only proviso for using period columns in your temporal table is that they have to be the datetime2 data type. You can have any number of decimal points from 0 through 7 behind that, but it has to be a datetime2 data type. And because it's system managed, it records the validity period per row whenever a row is modified. Temporal tables reference a history table, which I've already mentioned. It has a mirrored schema. In other words, all the columns that are in your main table, your current table, your temporal table, that table's schema, so all the columns and all the data types associated with them are mirrored into the history table. The names are created when you create the table. So as long as the names and the data types match, and folks, I don't even know if it checks to see if the column names are the same. I think it just checks for data types, but don't quote me on that. Don't make your life complicated. But it is a mirrored schema. And the interesting thing here is, yes, obviously it stores the history. But what's interesting is that the history table is page compressed by default. But if you create it yourself, then you need to manage that for you. So it's an extra bit of maintenance. So where possible, just let the system handle things. So when should you use temporal tables? Remember, we've got the 2 system versioning types. So now we're going to compare the 2 at a very high level. So when should you use temporal tables? When you want to audit all data changes and perform data forensics where necessary. This is my favorite part of this slide where it says, this is marketing. Microsoft is saying you can do forensics on your data changes, but it is in fact quite easy with the right permissions to delete a temporal table's history, to modify a temporal table's history, to drop columns, to alter data types. If you have the correct permissions, and there are sneaky ways and legitimate ways to get those permissions, then you can change the past. So I don't agree with the claim that it is useful for data forensics, but provided you can trust the data and provided that you've maintained a proper auditing environment, starting from the network application into your database, then you have a better level of trust on that data. And then, yes, you can audit all the data changes that have taken place. So we've spoken about temporal. So why would you use ledger tables? These are this new system version type in Azure SQL Database. What makes these different is that they use blockchain. Now, everybody's heard about blockchain by now. It's a cryptocurrency technology that is burning the planet, et cetera, et cetera. I, in fact, wrote a blog post on my website that was released this morning where I said that you probably don't need a blockchain. In fact, I said you don't need a blockchain. There are very few use cases where it makes sense. Ledger tables is one of those use cases, because what ledger tables does is it doesn't keep a record of all the changes. What it does is it creates a hash for every single transaction that is committed in the database. And then it bases the next hash on the previous one. So you have a chain of hashes or blocks of crypto, so blockchain, so that you can recompute that chain if you need to prove whether something has happened to your database. So it's not the same thing as temporal tables. You can in fact use the two features together. You can have your forensic analysis based on whether the data was tampered with using ledger tables, and you can store a history of all the data changes using temporal tables. So using them together is supported with some limitations. I just needed to hide something that was bugging me on the screen. So why temporal? Why would you use this feature? Well, we've already spoken a little bit about it, but you want to be able to reconstruct the state of the data at any time in the past. Well, that's not any time in the past. It's not magic. You have to actually turn the feature on and start recording those changes. So that sounds obvious, but in a disaster recovery scenario, people don't think clearly because they're in a panic, so they think that magic is possible. Temporal tables are not magic. You need to keep a record of the history. So that means you should turn on temporal tables when you create your table and not after the fact. However, the demo that I'm going to show you today is in fact the second scenario of taking a previously generated XML audit trail that has got its own table structure and everything, and then importing that into temporal tables. So it allows you to use the new features with old data. So that's slightly off topic, but you can use temporal tables to reconstruct the state of data at any time in the past using a simple select query. This allows you to do things like trend analysis. You can, instead of having to archive your data or push it over into a data warehouse that is aggregated, you can query the original data as it was at that point in time, and it goes into the history table. And as long as the data is in there in the history table, you can see what the data looked like at that point in time. And you can do it for every week, every month, every year, whatever the case may be. One of the cool features that people don't seem to speak a lot about that this would be useful is with slowly changing dimensions. So in your data warehouse or your decision support application, whatever it might be, if you have a dimension, as opposed to a fact table, you've got your dimensions that may change slowly over time. At some point, your dimension changes, then anything that was associated with that dimension before the change might break. And then you have to manage that with append-only tables and effective dating and all that kind of stuff. What temporal tables allows you to do is take that temporal table thing with that select query that does temporal queries for you, and then you can just manage those SCDs as you need them, the slowly changing dimensions, and you can link using those queries instead. So it's very cool for making sure that something doesn't break that changed in the past. This to me is the killer feature. You can recover from accidental data loss, accidental changes. Let's say you don't include a where clause, or your application does something and breaks the database. Well, yes, you can recover from most data change incidents. I say most because if you drop the table and you have the right permissions to do that, then the temporal history is gone. So it's not for everything, but this is a very powerful feature if you use it correctly. Nothing's for free. There's always a trade-off. If you have an application that exists and you want to go and apply temporal to an existing table, what you can do is hide the 2 period columns that you have to add on. Now, why would you want to do that? Well, it's to stop select star queries from breaking. And while we tell you as consultants never to use select star, I've got select stars in my demo. Everybody uses them, even though we tell people not to do it. So what we have here is a capability for you to add period columns to an existing table and then hide them from a select star query so that it doesn't break existing applications. I think that's a pretty cool feature. I'm going to pause here for a sip of my water. So if anybody has any questions right now, go ahead. Otherwise, I'll continue. All good? Still connected, aren't I? Somebody say something. Doing great. You see, I came and checked. I didn't hear anything. So let's go back. What are some of the limitations and considerations of temporal tables? As I said, nothing is for free. So if you create a temporal table, you have to have a primary key in that current table. And that's because you need to be able to identify each row uniquely. There cannot be a primary key constraint in the history table for that reason, because if you're taking rows from a table that has the same primary key but different history, that's going to cause a conflict. So you cannot have a primary key constraint in the history table. And you might think, well, I'll do it on the date and time columns. Well, no, because some transactions could affect multiple rows at the same time, even across transactions. So it's never wise to do a unique constraint based on date and time. So what we're saying here is that the history table doesn't have any unique constraints, and for that matter, it cannot have foreign key constraints or anything like that either, because you might have duplicates, you might have rows in a different table that they would refer to that get changed for whatever reason, so you cannot have constraints in the history table. What happens when you create your temporal table is that the history table will automatically get a clustered index on the 2 period columns. And that's just to make searching easier if you're looking for the SystemTime query, which I'll show you, the temporal query. History tables can be created manually or by the database engine, which I've already mentioned. The history table must be stored in the same database as the current table. That's to allow for the contract between the current and the history table to take effect, the referential integrity, if you like. The reason I mention this is because the demo that I'm going to present to you could have the audit trail in a separate auditing database. And that might be for legacy reasons. You may have had space constraints, or you didn't have a separate file group, or whatever the case may be. You put all of your audit trail in a different place, and now you want to use temporal. Well, you have to use the same database. Fortunately, we're in 2021 now. SQL Server 2019 is a full-featured product which allows you to create file groups. All of the features that were mostly Enterprise Edition features prior to 2016 Service Pack 1 are in Standard Edition and so on. And so you can get away with doing a lot more management of your files so that it can still be the same database logically, but your storage tiers might be separate, and you have your auditing, your history tables on a different storage tier. The history table is page compressed by default. Now, this does have trade-offs, and we'll talk about one of them further on. But the reason that this is important is if you create your own history table, it may not be compressed. And so if you're doing some sort of testing and comparison between you doing it versus the engine doing it, you may see different sizes, different performance metrics, and so on. And that's because it's compressed by default. Page compression has its own challenges when it comes to certain data types. And we'll talk about that soon. If you create the history table manually, you must enable compression yourself if you want to use that feature. This is one of those data type issues. Blob data types like varchar and nvarchar max, var binary max, ntext, text, and image. These data types are in most cases, they're already compressed because you are probably storing JPEG images, which are already compressed. You might be storing Word documents, which are zip files. You might be storing zip files themselves, which are compressed. And applying a page compression algorithm is a waste of time, because when you insert the row, it's going to try and do row compression first. It's going to fail because it's already compressed. And then it's going to try and do page compression. And just, it's not going to work. So if you have large objects sitting in max data type columns, then you're going to run into problems if you enable temporal versioning on that table if you do a lot of transactions, because it has to take the copy of that old row, write it to the history table, try and do compression, fail miserably, and then just carry on. So it's going to slow things down, and it's going to blow up your database file size because you're storing every single copy of that row. if you're only changing an integer column, it's still going to write away the entire row to the history table. It's the same as if you were doing triggers on the table and writing to a history or stored procedures, whatever the case may be. Just keep that in mind, please. Now, this one is kind of obvious, but I need to mention it. If system versioning is enabled, you cannot truncate one of the two tables, the history table or the current table, and you cannot modify the history table directly, which is to say that if system versioning is disabled and you have the right permissions, you can truncate tables. You can modify the history table directly. So while this is true when system versioning is enabled, anybody with the right permissions can turn it off and do whatever they like. There's a QR code for you to click on instead of having to search for that URL, or you can go and search in DuckDuckGo, which is the search engine you should be using, and search for considerations and limitations for temporal tables. I'm going to pause here and ask for questions. If not, I will continue. All good. We are steaming ahead. So, managing historical data retention. What does that mean? What that means is when the feature was first introduced in SQL Server 2016, if you wanted to clean out the history table for regular maintenance, like every 6 months or 3 years or whatever the case may be, you had to do that manually, which meant that you would have to cancel the system versioning connection between the current and the history table. Then you would have to go into the history table and clean it out, whether that be by partitioning and switching out a partition, or by doing a truncate or a delete from where the date was earlier than a certain time. And obviously that's not effective use of your time, especially if you have a lot of temporal tables on your system. So with SQL Server 2017 and higher, as well as in Azure SQL database, you have something called, I'll remember the name as soon as I show you the thing on the slide, because I've just gone blank. It's called retention policy. There you go. There are 4 ways that Microsoft says you can do your managing of retention. Stretch database. I'd be surprised if anybody watching this has ever used Stretch database, because it's expensive and has a lot of limitations. So I put it there because Microsoft recommends it, but don't use that. You can use table partitioning, like I said, so you can switch out partitions in your history table as long as that versioning break has happened. You can do custom cleanup, so a script that goes in and checks delete based on dates, and then the retention policy. Excuse me. The retention policy is when you create the table the first time as a temporal table, or when you alter an existing temporal table, you can set the retention policy, which is measured in weeks or months. So at some point in that future where it has transpired that that time has passed, then it'll go and do something similar to the way the ghost cleanup works. There's an asynchronous task that'll go and say, well, this row is before the retention period that I need to keep, so I'm going to leave that, but anything that's older than that, I'm going to remove it. And it's an asynchronous process. One thing that is, I think, a very cool feature from Microsoft is that if you restore a database that contains temporal tables, and if those temporal tables have a retention policy, that retention policy is disabled. Because if you're restoring a database and you're looking for old data, and suddenly the retention policy decides to run because you're getting a backup from 3 months ago, it's going to empty out your history, and that's not what you want. So if you do restore a database and you did have a retention policy on a temporal table, it will be disabled. And then if you want to continue using that restored database as your production database, you would have to then turn on the retention policy again. I think that's a pretty cool feature. So if you want to read more about data retention policies and things like that, then there's another QR code for you to use your mobile device, or you can search for the URL that is at the bottom there. And I think, if I'm not mistaken, that is the end of the slides. So, no, it's not. I always make this mistake because this is not a feature I recommend. Memory optimized temporal tables. This is the part where I do the uncomfortable silence, because you shouldn't use memory optimized tables if you are using SQL Server Standard Edition. Just don't do it. If you're not using Enterprise Edition, don't use memory optimized tables at all. Never mind temporal tables. You can use temporal tables, just don't use memory optimized ones if you're using SQL Server Standard Edition. Don't use memory optimized tables in standard because you will run out of memory. Your computer will blue screen if you're running on Windows, and you will have a bad day. If you're using SQL Server Standard on Linux, the kernel will run a process called the out of memory killer, and it'll just terminate the SQL instance. So while it won't blue screen that server, it'll still give you a bad day. So if you're using memory optimized tables of any kind, please don't do them on Standard Edition because you need more memory than you think you do. Please. Got it? Good. Now I'm going to tell you why you really shouldn't use them for temporal tables. Your current table is in memory. 2 thumbs up. That's the entire point of having an in-memory table, right? You've got a table that's got a lot of processing happening on it. You want to do, I don't know, a staging table, whatever. And yes, there is writing to disk, which happens through those checkpoint and delta files, but it's a little bit more streamlined than just the transaction log. Cool. Everything's happy. So when you go and add a temporal table to the mix, you've got to have a history table somewhere. And guess what? That history table is on disk. If it's on disk, it's going to hit the transaction log because everything that happens in your environment has to go through the transaction log, right? Guess what? You need to translate the way that the data looks in your in-memory table into a staging table that transforms it into something that can be persisted to the history table. Because in memory, it uses pointers. It doesn't use data pages like you're used to. So the internal staging table has to translate that row into something that is recognized by the regular buffer pool. And then it goes and writes it away to the history table. Cool. That's resource intensive. Yes, it is. And it requires more memory than you think. And here, it works on Standard Edition, but please don't do it. If I remember what I wrote in the administration book on SQL Server, for in-memory objects, if your table is 10 gigs, you need 40 gigs of RAM to handle that 10 gigabyte in-memory object. You need 4 times the RAM. Plus, if you're using temporal tables, you need even more than that. So Standard Edition is too risky, so don't do that. But please, Enterprise, go wild, because RAM's cheap now. So we have now reached the point of the session where I swipe over to Management Studio and walk you through a demo. I did this demo to somebody I work with just to let them know that I'm using their database. I changed the name of the database, but not much else has changed. So I did this in 10 minutes, so hopefully I'll stretch it out a little bit for you because I went really, really quickly. If you have any questions, please feel free to interrupt me. Otherwise, all I'm going to show you is that earlier, so 13:18, so about 40 minutes ago, I did a restore of this database. And now I'm just going to show you this real world example. What are we going to do today? We're going to go into real world demo here. We're going to go into tables. We're going to go into this table here called Audit Lookup. And inside the Audit Lookup is going to be a few columns. A primary key, which is a big int because we're potentially going to put more than 2 billion rows in there. We've got a table schema, which is text. We've got table name, which is text. We've got a computed column, which is the full name. We've got a table primary key, which is also a big int. So that way we can catch any types of primary keys that could be anything from tiny int all the way through to big int. We've got a user profile ID because we use stored procedures to capture the user ID from the application level. And then we use these stored procedures to send in the user profile ID using a token. And the token gets translated using a current table. It's not very complicated because it was originally designed in 2008. This is not meant to be complicated. This is meant to capture anytime a stored procedure does something against the database. If it does a database modification, it takes the old row and it writes it into here in an append-only model. So this table has a bunch of rows. and it can belong to any of the tables that have been modified. There's an audit and an effective date. The original intent was to have one of these being in UTC, but we never got around to it. So again, this is not perfect. And then right at the end is the table XML where the actual audit trail is stored. Now, because it's an append-only table, when any table gets modified, it writes a row here. So it's out of sequence. The only thing that is in sequence is the effective date. So it needs indexes. But we can't index XML data because, again, we need tons more space than we actually think we need. So if we skip the indexing on the XML, that means we have to have metadata columns, and that's exactly what these are for. So if we need to locate information inside this table, and I'm now going to show you what it looks like. Maybe I should actually choose the use command so I can show you what I'm doing. Here in this test database, this is not production data, don't worry. There are 152,000 rows, okay? So it's not a small database, it's not a small table, but it's also not massive. So it took 5 seconds to run this query. And each one of these sections inside, each one of these rows inside this table XML column has data in it that was audited. So for example, we're going to be looking at this vehicle table. MIB stands for Manufacturer, Importer, and Builder. It's a terminology for the vehicle industry in South Africa. So we've got schemas and so forth, and this is the vehicle table that says, on this date at this time, this vehicle was introduced to the roads in South Africa, and we keep a history of that. So if I click on this XML over here, it's going to open up a sample record of that history row, which is going to be obviously different to what's in the table right now. So if we want to do an historic query, we have to go into this table. We need to go and find the primary key, which is the vehicle ID in this case, which will be the table PK. We have to use the table name, table schema, and hopefully a date period so that we can narrow it down. So it's arduous to run a query against this, specifically because we haven't indexed the table XML, and it's going to take up too much space. So yeah, as you can see, if we go and expand out, I'm just going to scroll down on the left here to the vehicle table, you will see that the schema in this XML file, or this XML column, technically, matches the schema of the table itself. So we've got a primary key, we've got a foreign key lookup. For a dealer, we've got a bunch of string fields here. We've got a bunch of foreign key references to lookup tables and a bunch of other stuff. So it's a fairly straightforward production style table. And then right at the end, we have our own auditing. And this is the stuff that we use to figure out when a change happened. Again, because we use stored procedures to do this, we do everything in the stored procedure. If you use triggers instead, then you would do it in your trigger. I'm not advocating either way for which one is better because we're actually switching away to use temporal tables instead. So for this example, this company uses stored procedures. That's not the only way to do it. That's what I'm getting at. So I'm going to keep that XML open. I'm going to minimize this, and then I'm going to show you. Hopefully, I didn't close the file. Oh, I did close the file. And show you what one of the stored procedures looks like for doing an update against the vehicle table. So when we do an update, we need to record this information in the XML. So how does that happen? Well, let's go into our stored procedures. And of course, we're going to go to the MIB. We're going to go to update vehicle. And we're going to say modify because we're really classy being able to use the UI. And this has a lot of stuff going in it because there's also business logic. But the important thing that I want to show you is right at the beginning of the stored procedure, once we've taken all the parameters, what we do is we create a table variable, not a temp table, but a table variable, because there will only ever be one row in this in-memory object. Well, table variables are not in-memory objects, but I'm trying to make a point here. We're going to say there's only one row of data here that is going to be the old version of the truth, so that when the row is updated, we can copy that to the XML and store it permanently. So here's a table that is only going to have one row, so we don't worry about statistics or anything like that. That's why we can use a table variable instead of a temp table. And the schema is identical. And then in a transaction, we declare all of those metadata columns that I mentioned before, which on the left here were the schema, the table name, the primary key, the audit event, and all that kind of stuff. And we hard code those. These stored procedures are written by a tool, a code generating tool, and that's all checked into source control. So these are disposable stored procedures. If something changes in the schema of the table, we just run the tool and create a new stored procedure. It's fairly simple. But you'll notice here, we don't use UTC. We don't use UTC in this database because it's only being used in one country. There's no daylight savings, so we don't need to. South Africa is UTC +2, and that's all we know. If we see a timestamp in this database, we know that that's South African time. Cool. So here we have our regular update statement. This is what happens when I'm going to scroll up to the top here. When you run the update query, it's got a bunch of parameters, and that's exactly what we're doing here. We are updating the table with those parameters because that's what you do in an update proc. However, the output of the change, in other words, when you do a modification on a table in SQL Server, it creates in-memory objects called deleted table and inserted table. And depending on how many rows are affected, there will be 0 to that many rows that are in those two tables. So if I were to output the inserted stuff, it would show me the new row. But in this case, we're outputting the deleted row. In other words, the row that is being modified. So we're taking that output and putting it into that table variable. So far, so simple. And remember, it's a primary key. We're only doing one row. Then, using an XML query in SQL Server, in T-SQL, we go and generate an XML result set from that table variable. And here we've got XML auto, which means that it will look like this. It'll have the name of the table variable at the top. I regret using @t now because of the hex code, but what are you going to do? And then for every single node inside that XML will be the name of a field. So it's meant to be as simple as possible for humans to be able to read, because I might have been the person who designed this, but I'm not necessarily the person searching for this information. So it's going to need to be fairly easy to read. This is as legible as we could make it. And we use elements XSI nil so that any null values are persisted correctly. So a null value would be persisted as XSI nil equals true. Now a nil value, when you start working with tearing XML apart using T-SQL, sometimes it comes back as a null, sometimes it comes back as an empty string. Doesn't really matter. But as long as we have a record that that value is not meant to be anything other than a null or an empty string, we're okay with that. So once we have created that XML and we've put it into this XML parameter, then we just go and run another update procedure and we go and dump that into the audit lookup table as an append only, another row in the table. Done. And then there's a little bit of more business logic that happens here, which is related to how the process works for the tool. But from our point of view, once this XML is written to the table, there it is. So what we want to do now is we want to say, all right, we want to create a temporal table for vehicle. And this is what the temporal table looks, what the current table looks like. So our temporal table is going to look something like this. And I have made a terrible mistake for any of you watching, and now it's on the record. I used SP help, and I did not turn off show plan. So this is going to take a while. It's probably going to take about 30 or 40 seconds. So I'm just going to talk through it while we wait. So what we're going to do is we're going to take the vehicle table and we're going to turn it into a temporal table, which means we're going to have to add 2 new columns at the end for a valid period, from and to. Then we're going to create a history table. And then there are, excuse me, there are 2 ways to, yeah, I'm just watching this progress bar. It seems to have hung. So hopefully I won't have to restart Management Studio. So what we're going to do is we're going to take the history table, and there's two ways to do this. Either we can generate the history table ourselves using a create SQL statement, or we can ask the engine to do it for us. But because we're creating it using the engine, we will then have to break the system versioning that joins them together so that we can make another modification. Because the modification I want to make, look how fast SB help is if I turn off include actual plan. Oh, look, it's done. So it does a handy tip. It even says turn off view execution plan if enabled, and I didn't read that. So what we're going to do is we're going to take everything from the audit table that matches MIB vehicle. So here's that schema that I was talking about and table name. This is how we find information for each of the audit trails that we want to look through. And there's 2353 rows in this database for the history of the vehicle table. So we want to convert the MIB vehicle into a temporal table, import the audit data from the append only XML, enable system versioning, and remove the old XML, because why keep the audit trail twice? Simple. Well, it's simple, except that we want to create a separate file group for the history table to manage the storage allocation better. We want to go and put the temporal table's history in a separate file group so that we can keep it on cheaper storage, because we don't need gold tier, because we're not going to be querying it as much as the current table. So how does that work? Well, firstly, I'm going to create a new file group called history, because I'm really original. And I'm going to create a new empty file called RW for real world, except it's Randolph West, let's be honest. And it's going to be 8 megabytes, and it's going to grow by 8 megabytes each time. So that's what we've done there. Then we're going to go back to our database, which now has a new file in a new file group, and we're going to create a schema. When you create a schema, it doesn't automatically assign it to a file group. But what you can do is you can now, when you go and create objects in that schema, you can use techniques to move the data that is in the primary file group into that new file group. So this is a logical separation, the schema, and then the file group is a physical separation. I've got a lot of writing here that says you may have to add new columns for period validity, a start and an end time. Now, because this table already has a modified date column, we can use the information inside that column, but we cannot reuse that column because it's not in UTC. Temporal tables require you to use UTC timestamps because, guess what? You don't have to worry about things like daylight savings, right? So that is or time zones for that matter. So that is why temporal tables require you to store everything as UTC. So because we have the data we need, it's already in South African Standard Time, so we have to convert it. So we cannot reuse the column, but we can reuse the data inside that column and copy it over. This is where the hidden keyword comes in. I will reuse the data from change date and add 2 new columns, valid from and valid to, and hide them so that any select star in existing code won't break. So because we cannot modify the existing column, we have to add these 2 new columns. And I'm going to go through the syntax here. Some of the syntax that I'm going to show you is not required because the default values are already implied, but I'm going to walk through them anyway. So we've got an existing table, which is called vehicle, that is not a temporal table. And the way you can tell a temporal table is the icon changes. And I will show you that once we've actually made the change. It's the same for Azure Data Studio as well. If you're looking at it in a UI like this, the icon for the table will change and it'll actually say system versioned behind it. So we're going to take an existing table and we're going to add 2 new columns, valid from and valid to. They will be date time 2 of 3, and they will be generated always. Why did I choose 3 decimal places? Because that's millisecond accuracy. It is better accuracy than the regular date time format, and it uses 1 less byte. So if you look at the documentation for date time 2 with 3 decimal places has millisecond accuracy, and it only uses 7 bytes per column per row. Whereas date time, which is 3 to 4 millisecond accuracy, uses 8 bytes. I've written an entire series about data types in SQL Server, and thanks to Jeff Moden, who you may know as the person who came up with the phrase row by agonizing row, or rebar, we had a conversation in the comments of one of those blog posts, and we were able to use that information that we gathered to correct Microsoft's own documentation. So that's a bit of an aside to say that you'll learn any cool number of things from the comment section if you're dealing with people who are having a good faith discussion with you. So I always enjoy that kind of conversation. So generated always is telling the storage engine, hey, you need to do this for me. I don't want to do this. This is your job. And because it's a temporal column, we're going to do it as row start and as row end, as you can see in the second example there. And we're marking them as hidden because we don't want a select star query to break and cause endless havoc, because now there are 2 extra columns that it wasn't expecting. This bit at the end here, this default constraint, is optional because by default, temporal tables use UTC, and they will create a default constraint for that value. Here, by defining the name of the default constraint, we get control over what its name is. Otherwise, it comes up with a random name based on the object ID. This is just for clean coding and checking in objects and stuff like that. Same thing that we had in valid from, we also have in valid to. It's the same date time 2, 3. It's generated always. This time it's row end, which I showed you. It's also going to be hidden, and it's got a default constraint. This time the default is set to the year 9999. If anybody's worried about the year 10,000 problem, I'm not worried about it. So if SQL Server is around then, I'll be impressed, seriously. And surely then the default constraint just needs to be bumped up by another 10,000. Notice here that I've specified the format that includes 3 decimal places. That's just a matter for my peace of mind. I can leave this entire thing off and just have that, and it'll do exactly the same thing. I'm just showing it to you here for completeness. Let's alter this table and add those, and then you'll notice there's a comma and period for system time. For system time is the SQL standard. Oh, look, I've already broken this. For SQL, I love my job. For SQL, for system time is a SQL standard that allows you to run queries, basically. So run queries that are temporal in nature. So if you do, there we go, that should just work now. There we go. So if you do a temporal query, you need to use the keywords for system time at the end of your from statement. So you say from table, whatever, for system time, and then a bunch of parameters to allow you to do those point in time queries. So what we're doing here is we're just setting up the engine to understand that when it creates a history table, it needs to join these columns because we specified their names as the system time columns. Are there any questions so far, or can I just keep going? I cannot see yours, the Q&A, so if somebody can just jump on the mic and say everything's cool.
Yeah, you're looking good, Randolph.
Good, thank you. So what we're going to do now is I'm going to show you a select star query, but notice I've specified valid from and valid to because you need to specify those because these columns are hidden. I'm actually going to show you that now as well. So if I do a select star from here, well, of course it's not going to work because I did a comma. If I do a select star, those 2 columns that we added, valid from and valid to, are not there anymore. That's why we need to have them specified in the select statement, and that's what prevents things from breaking. Now this is cool. We've turned on system versioning. Now we need to set up a history table. And you'll notice here the valid from is the moment in UTC that I created that I ran that alter statement. Now what we want to do is we want to create a history table immediately and then drop the system versioning because we're letting the engine create the table, create the clustered index, do the page compression, and then we're going to turn it off so that we can backfill the history. So that's what's going to happen here. I've created the table, the history table, and then I immediately turn off system versioning. So if I go here and I refresh, this is still not a temporal table, but we will if we go up to here and refresh and go down to H, we should see history vehicle. This is our new history table that was created by the engine not a few seconds ago. And the columns will be the same as they were in the vehicle table. The only difference is there's no primary key constraint. Cool. Now, why did we do that? Because I want to remember the logical versus physical separation. I had the history table, which is a history schema, which is a logical separation. Now I'm actually going to move that clustered index that it created into the history file group so that we can physically move the data from the history table into that new file group. So it takes it out of the primary file group, whatever the default one is. And that's what that is. By the way, I mentioned this before, the clustered index that it creates automatically is only on the 2 period columns. It doesn't need to be anything else. Now what are we going to do is update our vehicle, and we're going to set the value of valid from to be UTC time based on the change date. And so we have to do a date add using -2. So what's going to happen is 4,000 rows in the vehicle table have now been modified. So how do we prove that? We go into here, and select star is going to work because we've turned off system versioning. Those hidden attributes are no longer valid. Hidden attribute only works if the table is a temporal table. But remember, we created the temporal table with the history table, and then we broke the link so that we could backfill. So that means the hidden constraint is no longer visible. It's no longer a thing, so we can see the rows here. And sure enough, my change date here is in South African time. And then the valid from right next to it is in UTC. I subtracted 2 hours. Nothing very complicated there. Now what we're going to do is re-anoint the vehicle table as a temporal table. We're going to reconstitute the system time period because we've now set the valid from and the valid to. Makes sense. So let's do that. And now we re-hide those 2 columns. Now this syntax is a little bit tricky, and it took me a while to figure this out. And when I say a while, it took me 5 minutes, but watching me Google things for 5 minutes is boring. So I've made life easier for you. It uses an alter column. You don't have to use any data types or any other constraints here, but you do need the add keyword to apply to hidden. So we're adding the hidden property to this column in this table. I hope that makes sense. So did I do that? I think I did that. Shall we check again? Cool, it's done. Now the history table that we've done should be empty, but if we go and have a look at the history table here and refresh it, because we moved the clustered index into that new file group, we should just be able to go into the properties here and go into the storage section. And firstly, you'll see that it's page compressed by default, and you'll see that the file group is set to history. So it's going to be moved into its own file group for better management of storage. Then what we're going to do is double check the amount of rows that we're taking from the audit trail and putting into the temporal. So we're going to take 2,300 rows from the audit trail that's in XML format in a very difficult to search form, and we're going to transpose that into a temporal table history file, or table, should I say, and that is going to be more easily queryable from regular select queries. So I'm going to put whatever is in the XML. I'm going to do an XML query that parses out every single one at a time, row by agonizing row. Thanks, Jeff. Using rebar, so it's going to take a lot of memory. It's going to take a lot of CPU cycles. On 2,300 rows on my server, it's going to be very quick, but I want you to keep in mind that anytime you query XML, it's actually creating an in-memory object that is a relational version of that view. So please take care when you do this on a production system. So how does my query look? I'm just going to hide the results grid for a second here. As you saw, there were a number of columns inside that vehicle table. So for each one, remember we have the table XML. This is what I'm referring to now. For every single row in the audit trail, I have one of these. And so for each one, I'm going in and looking at each node, and I'm querying the value for that node represented by a period, and then the data type that it needs to convert it to. Excuse me. Now remember I said that even though we're storing the null values as null in the XML, this is where it gets converted into empty strings, because I haven't actually said if it's null, set it to null, otherwise set it to an empty string. I could do that. There's nothing stopping me from doing that, but just for the demo purposes, all I'm doing is saying, I know that license number is an nvarchar field, and if it happens to be null, just make it an empty string. And that's all that this is doing, is it's doing a select into this temporary table from Audit Lookup where the table schema and table name matches. So it should take 2,300 rows and convert them into a single table in the TempDB, which is in the right format. And there it's done. Now that appeared quick because I have a fast server and only a few thousand rows to deal with. But if we select directly from that temp table, we now have 2353 rows down here, which you can see. So that's the right number. And we'll also see, I'll just scroll across here, create date and change date, which are, again, South African Standard Time. We need to make sure that we capture the UTC value. And now we just need to convert this into the history table, or just take it and dump it into the history table. There's a couple of minor things you have to think about. And as we come to the end of our hour together, this part will not be complicated. So we're not out of time just yet, and everything is cool. When we go into the temp table and we want to reconstitute the valid from and the valid to, we're going to run into a problem. And the problem is, at some point in time, we'll get to one row that doesn't have a valid to value because that's just not available in the audit trail. That value will be in the current table. So we have to then go and do a join against the current table to get whatever the valid to period is for the current row. So in other words, the most recent change, we need to go and grab that from the current table in order to backfill this history correctly. So I'm going to create another temp table, which uses almost exactly the same data. The only difference is I'm converting the change date into a UTC value and putting it into the valid from. And then I'm also doing a lead windowing function, which says that for this vehicle ID, because I'm partitioning by vehicle ID, for this vehicle ID, go and find me the next value. And then we're going to use that value as the valid to for the current row. So we're going to use a future value for the current row so that we can know how long that row is valid for. And that's going to be fairly quick as well. And we're just going to check this out, and we're going to see a couple of null rows in here, 820 to be exact, because out of the 2,500 rows, we had a number of values that we now know that the valid to column is in the current table. So let's go and fetch that. And this is a fairly simple query. We're doing an update from using an inner join, and we're checking to see where valid to is null in the history. And we're going to do a conversion to UTC time at the same time. And there's our 820. So if we check our new table, our new temp table, there are no null values now. And if we go and look at across, we will see valid from and valid to have been populated successfully. That is now your history table. So the next step is to make sure that the history table is empty and insert into the history table whatever is in that temp table. And I'm just going to run that quickly. And there's our 2,300 rows. And now all we have to do is set system versioning on, because we've already got the history, we've already got the current table. Now let's join them back together again. And that's as easy as that. Here is a temporal query saying, show me all the current data and all the history from the temporal table using a for SystemTime all, which means it's going to go into the current and the history and concatenate them together. Sure enough, there is a vehicle ID that I picked randomly, 7539. This is the current row at the end because I did an order by valid from. And you'll see there that is set to the future, 9999. But you'll see the history here. Each of these matches the time that the event occurred. So you can trust this provided you followed the right things of the history, and you don't need to run complicated XML queries to do so. Plus, you will reduce the amount of data that you're using for your audit, because guess what? You're now going to go and delete those rows from the audit trail, and Bob's your auntie. So that's the demo. That's it. I'm going to turn off sharing if I can remember how. I don't remember how because I'm blonde. There we go. Hi.
There you go. So you followed it all nicely, and it will all come together. I mean, I think that is a neat piece in being able to kind of retrofit a table, right? Because I think a lot of times, and that's kind of where my question was going to be, is when do you decide to implement this? And your response, or what you kind of showed us, is that, okay, well, it doesn't matter because you can always go back, bring that information in, and then just keep going as if you always had it, in a sense, right?
Right. And what I like about this approach, specifically because we're using stored procedures or triggers, it doesn't matter. And because we're using code to generate those things, we can replace the stored procedure if we need to and take out that thing writing away to the audit trail and just let temporal tables handle it. We can do piecemeal conversions, so we don't have to convert the entire thing in one evening during a small maintenance window, stuff like that. Yeah.
Yeah. That's nice. And then, so in terms of setting up that temporal table, right, now we have that history. I mean, obviously, so now we're adding the time to our queries. Do you find that we're adding a lot of extra? Well, what's the word? I guess what I'm saying is, what refactoring has to get done for the applications to now use that, or is it really more of an audit piece? Like, so the application proper is not so much using it, but we are just like as a one-off or a special case want to go back and look at that history. Does that make sense? What I'm asking?
Yeah, and you've answered your own question by saying it's a case-by-case basis. It depends. I'm going to say that.
But you mean there's no hard and fast rule here? Come on.
If your application does need to run point-in-time queries and stuff like that, then you could create either dynamic SQL or stored procedures that do it for you, that take a parameter, and then you could create that for SystemTime query and return the result sets for the application, or you can do it yourself manually as the DBA, whatever the case may be. There's case-by-case basis. There's nothing stopping you from writing code for your application to query that history data to do that point-in-time stuff for report generations and things like that. It depends.
Sure. I was going to say, Mariano, if you want to raise your hand, we'll actually bring you up on stage if you'd like. I'm not sure why you don't have access here. But while he's doing that, yeah, there we go. So his question is, right, you mentioned there always be trade-off in temporal tables. What are those trade-offs? And let's here he goes. Here he comes.
So that's a good question, Mariano. The first thing that I would say is make sure that you're not turning on temporal because you think it's a cool feature. You need to make sure that the limitations are within your business's acceptance criteria. So I mentioned the blob data types. So if you've got a SharePoint style database like SharePoint or project server or nav or anything that's doing some of that janky stuff with large blobs and versioning, you probably don't need temporal tables on those tables. The other thing is you cannot use file stream. I think that's one of the limitations. That's why I pointed to that URL, because there's a lot of stuff that might be a gotcha that you didn't think about or consider. And obviously, if we had 90 minutes, then I would go through the whole list, but we don't, unfortunately. Plus, I wanted to get to the demo because I think that's a good example of when temporal is good. But when I say it's not free because your history table does require resources. That page compression algorithm is fantastic until it's not. So if you've got a lot of transactions that are being pushed through, it still has to compress every single row and then every single page that contains all those compressed rows. So it can get computationally expensive and cause more work for the CPU. That being said, there's a bunch of stuff that you need to test. yes, it generates more CPU, but is that actually going to cost you anything, or is it within your acceptance criteria?
Right.
Oh yeah.
Obviously, the amount or the amount of transactions coming through would be a big indicator, but I feel like generally speaking, right, the compression CPU that we're seeing is a couple of percentage points,
Yeah.
and that's generally not enough to like make or break it, right? I mean,
right. If you're running SQL on an edge where 5% makes a difference, you're over your limit anyway, and
right,
so
right.
yeah, take that into account. That's a great question, and I also wanted to mention here that when you use something like ledger tables, which I was one of the early testers for the feature, when you use something like that, it's for proving that something happened, but that doesn't mean that there's information there that you can use as well to see what the changes were. So you can see at what time a transaction occurred, and using your other audit trail as well as temporal tables, you can use that all together combined to actually provide quite a robust, and not a perfect, but a robust auditing trail for your environment. So there's ups and downs. What's the thing? Stairs and roundabouts or something? I don't know. I'm not from here. Swings and roundabouts. I knew I'd remember it in the end.
And I have something related with this. Is there any incompatibility with some other features of the engine when I turn on this? Like, for example, always on replication, those kind of features, or no?
No, but there's things that you have to think about when you do that. So your history tables need to exist in both sides and all of that kind of stuff. So there's more to think about, absolutely. Do you need to replicate the history table? I don't know. What's your business requirement? Maybe. Right. It works with AGs. Again, you have to make sure that the tables are the same on both sides, because AGs are just shipping logs, basically. So yeah, as long as the structures are correct on both sides, you should be okay. The big thing for me is that before 2017 came out was you need to clean up that table, because it's going to blow out quicker than you think, especially if you're changing one or two columns at a time. It's still writing the entire row to the history.
Right.
So yeah, keep that in mind.
Excellent. Thank you, Randolph.
You're welcome. Thank you. Great questions.
So with that transaction, I mean, process or piece of it. Now again, right? It's going to vary. I'm thinking here of a multi-database scenario, right? Where you're kind of separating some of those pieces to help reduce it. So can that be bulk logged to help reduce some of the writing to the transaction log? Do you know that?
I don't think bulk logging is going to help you here.
Okay.
Because it's each row that gets committed to the table, one row at a time. With ledger tables, it is per transaction. So you'll have a transaction ID attached to each row that is modified in that transaction scope. But for temporal tables, although it is scoped to the transaction, it's row by row.
Gotcha.
So, for example, and I did a test way back in 2015 when they first announced this feature. If you were to do your own auditing using triggers that just writes to a history table versus doing it through temporal, the transaction log is identical. There's no difference as far as the T-log is concerned, whether you're using temporal versus your own rolled triggers. Mm-hmm. The only thing that's happening is that the old row is being copied and put into this new table, or the history table. So as long as you've got that fairly quick, and as long as your transactions are small, you're not modifying a whole bunch of data, it's going to be a net win, because instead of having to write away to an auditing table that is XML and massive. Sure.
Yeah. Very good. Awesome. Well, I don't know that I see any other questions, but thanks so much for being here. Right.
Thanks for inviting me again. I've missed you.
Yeah.
I've missed the in-person thing, and I've got to say, AirMeet is one of the better virtual environments, and I was very happy to participate in your one earlier this year. So yeah, I think you've got a good setup here, and yeah, I wish you well going forward, and hopefully we can do another in-person one, and can invite me again.
There we go. Hey, that's right. That
And I'll wear my OG shirt again.
That's right. I was telling him we had a small in-person gathering here over lunch last week, just for folks in town, right? And I wore my shirt, and I was like, "This is limited edition, right? There was only like 20 of these ever made, right?" Like, okay, very good. Well, awesome. Thank you, sir.
Carlos, again.
Yep. Thanks, everybody.
Thanks.
SQL Data Partners.